So up to this point we've covered the three pillars of object-oriented programming. And that's fine, except that we've covered them very separately and very distinctly. How do we actually bring it all together? How do we actually build a program using these techniques? Well, we really need to know how to design an object-oriented program. Up to this point in previous courses, you've learned how to flowchart programs, you've learned how to use pseudocode. Now we're going to come across a new format, and this is a really professional level design concept, and we're going to learn the basics of it. There is a lot more details to it, but we're going to learn how to, generally speaking, perform this design method. So what we're going to learn is something called UML. UML, which stands for Unified Modeling Language. And really it's just an idea of drawing class diagrams, which you already know how to do, and figuring out how they interact with one another. What touches what can speak to what, and how many of what does one own to another one. So how do we actually do that? Well, it all starts with a basic description. So whether it's an assignment from a teacher or whether it's a specification sheet from a client or whatnot, that's what you have to go on. Sometimes it's enough, sometimes it's not. So we're going to go through a process that will hopefully give you a basic idea of what to do. The problem is it's not an exact science. And I'll teach you some general tips and tools, but at some point it's just going to be experience and practice and common sense that are going to help finalize your ideas. It's not going to work perfectly every time. So you're going to have to learn as you go. So generally speaking, we're going to follow a process called ITOAD. I-T-O-A-D. Identify, to other accessible, and define. So generally speaking, what do all these mean? Identify, this is really the key to the whole process. Identify means identify the objects and the attributes. So given a specification sheet, so maybe it's a description, oral or verbal or textual or video, or some way you got some type of specification from a client or a teacher. Your job is to take that description of what's desired and come out with something finalized, a finalized design, using this unified modeling language technique. So in order to do this, we're going to use a method called noun, verb, adjective. And yes, if you do some research, you will find that it's an imperfect option, but there is no perfect option. A lot of people will describe different methods and strategies, but nobody's come up with some surefire way. At the end of the day, it's going to be experience that helps you become a better designer. So the way this works is, given a description, a verbal or a written description, write it out, and then once you've written it out, I want you to circle all the nouns, I want you to underline all the verbs, and I want you to highlight all the adjectives. When doing this, you're going to use this technique to really pull out this information. Think of it like looking at a word problem in math class. You really want to pull out the important information. All your nouns are potential classes. I say potential because you do still have to use your judgment. Your verbs are potential subprograms. And your adjectives are potential attributes. So this identify portion is really the hardest part, is pulling it out and breaking it down into its finer components. So once you have the identify piece done, you need to determine what can be done to each object. And really, this really means this helps simplify the verb action, so potential subprograms. This is really to narrow this piece down right now. Other is really how the classes interact with one another. So what we're saying when we say other, we're saying determine the parts of each object, determine what each object can do to other objects. How can one object communicate with another object? Does it need to communicate with another object? Start writing this information down. And then we get into the accessible portion. So this is really looking at the parts of each class and saying what is accessible to other objects. Essentially, what is going to be private, what is going to be protected, and what is going to be public. So remember, this is just for the class. This is for children and the class. And this is for everyone. So you got to be careful and use that sparingly. So once you have that, you get into the final piece, which is define. Define each object's interface. And this is really what are your public subprograms? So public subprograms. How do other classes actually communicate and talk and direct this class or each individual class? So these 5 pieces, ITOD, identify. So identify the pieces, the nouns, the verbs, the attributes, the objects. What can each object do to each other object? What can be done to each object? What can objects do to other objects? What is accessible to other objects? And what is the public functionality available to the other objects? So, with all this in mind, how do we actually formulate and do something and use this effectively? Once you've come up with your nouns, your verbs, and your adjectives, this is going to be the most difficult part. Get that done, and then you're going to come up with some type of class diagram, a set of class diagrams. Let me just quickly get rid of some of this. Let's do it the easy way. Delete. And once we have all of our class diagrams, you might have, let's say you have one here, and you have another one over here, and you might have a couple down here. Just to simplify the process, let's call this A, this B, this C, and this D. Now what we want to do is, once we have all these class diagrams set up, we want to figure out how can we show that they're communicating with one another, and in what way do they communicate, how they're communicating with one another. To do this, we're going to use a few different shapes and designs. So first of all, with your class diagrams, let's talk about accessibility. When we have accessibility, we're talking about private, public, and protected. Now normally when you set up your attributes or behaviors, you may have something like this: int age. What I want you to do now is specify whether that int age is going to be private, public, or protected. To do this, we use 3 symbols. Plus means public, minus means private, and the pound sign, or hashtag for you kiddies out there, means protected. Now let's say, for example, A is going to be a base class for C and D. Maybe I want age to be protected, so I put that little symbol just before the int. And the same symbol would appear before any behaviors down here as well. So that sets up our accessibility. The next thing we need to realize is it also handles, our public functionality, our public interfaces and whatnot as well. But the next thing we really need to figure out is how they actually communicate with one another. To do this, we're going to use a series of arrows. We're going to use a black diamond arrow. We call this our composition arrow. What this really means, this is a composed of relationship. This is colored in. And then we have our inheritance arrow. And as you already know, this is the is a relationship. So I just mentioned that C and D are going to inherit from A. So that essentially means that C will inherit from A. D will also inherit from A. Notice that I don't draw a second arrow into it. Every object should essentially only have one arrow coming into it. Very rarely will it have more, but sometimes it does. Depends on the program itself. Now let's say, for example, A holds an array of B's. So maybe it has an array of B's, and let's say this is public. So that means that A is composed of B. And the way that we draw that is we draw the black diamond pointing into A. So we're saying that A is composed of B. And we look at this and we have to specify a little bit more information. So far we know how they communicate. We know that C and D are subclasses of A. We know that A holds a collection of B's. It's composed of B elements. But what we need to really now specify is, well, how many of B is A composed of? So let's say, for example, this is not an A, this is a car. And B is not B, it's a tire. Well, a car is composed of how many tires? Well, a car is composed of 4 tires. A tire is associated with how many cars? A single tire is associated with only ever one car. It's only ever attached to one car at a time. So the way we read this, we say a car is composed of 4 tires. A tire is associated with one car. We don't need any numbers in the inheritance because there's no composition here. It's just saying that C and D inherit from car. These number systems that we use here and here can be shown in a number of different ways. They can be exact numbers like you see here, or they can be a range of values. So for example, we might see something like this, 0.1. That means the value is going to be anywhere from 0 to 1. Or we might see something like 0 ... star. That means that it could be anywhere from 0 to infinite. We might see something like, let's say 2 ... n. That means that it's going to be anywhere from 2 to some finite value. So it's not infinite, it does stop somewhere. So for example, if we're talking about, instead of car, vehicle, and we look at tires, some vehicles may not have 4 tires. Some vehicles may have 2 tires, like a bicycle or a motorbike. These have 2 vehicles. Some trucks and small cars have 3 tires. We know they're going to have at least 2, unless of course it's a unicycle, in which case it might be 1 ... n. And that's really up to the designer. They have to decide how that's going to work. So using all this system, we see this basic UML diagram. We have one driving class, which is the car in this case, and the car is composed of tires, but each car has 2 subclasses. So maybe this is like, oh, I don't know, a Ford, and this is a Chevy or something like that. And they have specific information. It's really not that important right now. So using this, we have our built-up design, and now we can use our design and actually put it into action in code, but not until we're happy with it and comfortable with it. And that is it.